So in this video we're going to talk about determining whether conditions are met and constructing and interpreting a confidence interval to compare two proportions. Okay, we've done proportions enough at this point that when we talk about conditions we know what they are. The first one is random. Okay, for both populations we're dealing with two different populations now, so both populations have to meet the random condition. Both populations have to meet the 10% condition. So of course N1 has to be less than or equal to 1/10 of capital N1, and N2 has to be less than or equal to 1/10 of capital N2. And then large counts, N1, P1, N1, 1 minus P1, N2, P2, and N2, 1 minus P2 all have to be greater than or equal to 10. And we talked about that a little bit in the last video. Okay. Now we know that on the AP test conditions will be met. We just have to show that they are. Okay, so if we're going to compare these, we're going to make a confidence interval. We're going to make what's called a two-sample Z interval for the difference between two proportions. And it looks like this. When conditions are met, an approximate C% confidence interval for P1 minus P2 is P hat 1 minus P hat 2 plus or minus Z star times the square root of P hat 1 times 1 minus P hat 1 over N1 plus P hat 2 times 1 minus P hat 2 all over N2. So we've seen something like this before when we did confidence intervals. Now we just have more than one proportion. This is the difference between proportions. Okay. Now it's going to be very important, is 0 in the interval? That's going to be a good question. Is 0 in this interval? Because if 0 is in the interval, if the answer is yes, okay, then they could be the same. They may not be, but they could be the same. The proportions could be, we always say could be, equal. It could be the same. If 0 is not in our interval, then there's evidence the proportions are not the same. Okay, so if 0 is in the interval, then there's not evidence that the proportions are not the same. We don't know that they're not the same, but it's possible that they're not the same. We don't know that they're the same, but they could be. So yes gives us less information because we can't really be sure. But if it's no, then we can say there's some evidence that the proportions are not the same if 0 is not in our interval. Okay, so let's look at an example here. Many news organizations conduct polls asking adults in the United States if they approve of the job the president's doing. So how did President Obama's approval rating change from October 2012 to October 2013? According to a Gallup poll of 1,500 randomly selected U.S. students on October 2 to 4, 2012, 52% approved of Obama's job performance. A Gallup poll of 1,500 randomly selected U.S. adults on October 5 through 7 showed that 46% approved of Obama's job performance. So we're going to calculate the standard error. We want to use the results to construct a confidence interval and then decide if there's evidence if his job approval rating has changed. So let's do our solution to this. I'm going to start with A. Okay. So we're just going to calculate it. We'll worry about conditions later when we do our confidence interval. Let's just calculate it with what we know. It would be with our formula P hat 1 times 1 minus P hat 1 over N1 plus P hat 2 is 1 minus P hat 2 over N2. So in this case that would be the square root of 0.52 times 1 minus 0.52 divided by 1500 plus 0.46 times 1 minus 0.46 divided by 1500, and that turns out to be 0.0182. So that's the standard error, sometimes known as standard deviation as well. Okay. So our solution for B. Oh, and if we interpret this, I should interpret this. I nearly forgot to do that. If we interpret this, okay, interpret this error, this standard error. Okay, what that means is if we repeated this survey process many times, back in 2012, 2013, the difference in the sample proportions will typically be off from the true difference by 0.0182. That's our interpretation of it. It's always the same. It's just a matter of writing it out. Okay? So it's always about repeating that process over and over again, and that how much it would typically be off by. Okay, so the now we want to construct a confidence interval. If we're going to construct a confidence interval, we have to do conditions calculations and conclusions, as we always do. So first we're going to say, as part of, right before we do conditions, so we will construct a 90% confidence interval for the difference in support, in proportion of support for President Obama from October 2012 to October 2013. We're telling them what we're going to do. We're going to construct our 90% confidence interval. Now we have to talk about conditions. Our conditions: random. It tells us in the problem both samples were chosen randomly. Okay, they told us that. We just repeat it. 10%. For both years, there are more than 10 times 1500 or 15,000 U.S. adults. And large counts. Well, n sub 13 equals 1500, and so we want to do an n sub 12 also equals 1500. P sub 13 is 0.46 and P sub 12 is 0.52. So if we do our multiplication here, we would do N13 times P13, which is 690. N13 times 1 minus P13 is going to be 810. Okay. N12 times P12 is 780. And N12 times 1 minus P12 is 720. All are greater than or equal to 10. Okay, all are greater than or equal to 10. So our conditions are met. Now, we have to do our calculations. And we're going to do it with 2-prop z int. Okay, 2-prop z int. And we're going to put in, what we put in is x1, which we decided was 690, and n1, and this is what the calculator has, 1500, and then x2, 780, number of successes, n2, the sample size again, and then our C percent level is 0.9 or 90%. So we're just telling them what we're putting into our calculator to get our answer. We're not going to do the calculation by hand. And so what we get is it gives us an interval from negative 0.09459 to negative 0.02451. Okay. And our conclusion here, because we have to interpret this confidence interval, we are 90% confident that the interval negative 0.09549 to negative 0.02451 captures the true change in proportion of support from October 2012 to October 2013. Okay. So we've answered that question. And now we had one more question to answer. Based on your interval, is there convincing evidence that Obama's job approval rating has changed? Well, it's a question then for C, for our solution for C. The question is, looking at our interval, if 0 is in our interval, then we can't say we have evidence that it's changed, because it may not have. But since 0 is not in our interval, we have evidence that the rating changed. The rating changed. Okay, since all values are negative, evidence suggests support went down.